Welcome to the project demonstration of PC RF based energy meter monitoring system. So here we are going to monitor the energy meter data in kilowatt hour on this PC through the RF communication. So whenever the data will be read by the microcontroller in terms of kWh readings, so that will be transmitted through the RF receiver module, and the data will be received by this RF receiver module, but it's going to be the TTL data. So any processor, like any processor in laptop or PC, can't understand the TTL data. That's why we need to convert that to USB. So this is the PL2303 TTL to USB converter. So the data will be received from this module and it will be displayed on your laptop. For that reading purpose, we are making use of Hyper Terminal software. So initially we need to install the respective driver for this PL2303 and then Hyper Terminal. These two are the main required softwares in the laptop section. Coming to the hardware section, we are providing 230 volts AC input to the energy meter circuit. So that is the energy meter input, and from there we are distributing that parallelly to this regulated power supply board. So it has the 4 stages: transformation, rectification, filtration and regulation. Transformation to step down the 230 volts AC to 12 volts of AC, rectification for converting AC to pulsating DC, and the filters will remove the pulses and we will get the pure DC voltage, but it's going to be the 12 volts, but the operating voltage for a microcontroller and RF module is 5 volts. So we will use a 7805 regulator under this PCB. We will get the 5 volts DC constant. So that DC is the input to this microcontroller 28 pin board. So from here we are distributing that to the RF module and PC817 optocoupler. So here the optocoupler purpose is which will read the data from this energy meter. So here the energy meter consists of LEDs. In that, one LED will show the status of the load. When that particular LED blinking rate reaches 3200 blinks, then it is an indication of 1000 kilowatt were consumed per hour. So proportionally we are going to converting one blink is equal to 1 by 3200 kilowatt hour. So that is the ratio for each blink, and that will be identified by this PC817 optocoupler. So this will isolate the between the energy meter and the microcontroller. If is there any short circuit occurred inside this energy meter, so this wire is directly connected to the microcontroller, then the microcontroller will may get damaged. In order to protect that, we will place the optically coupled IC, that is PC817. Only this IC will may get damaged if any short circuit occurred, so that we can protect the main motherboard along with RF transmitter module. So here same pulses will be given as input to the timer pin, that is the A4 pin of our PIC16F72 microcontroller. So on this motherboard we can see the reset switch to restart the microcontroller, crystal oscillator to provide the 20 megahertz of clock frequency to the microcontroller, and RF transmitter, RF transceiver will be connected to the B0 B1 pin to this one. So that's the transmitter section, and the load was directly connected to the output of our energy meter. So coming to the receiver section, so initially we need to install one application which we have provided. So already we have installed, but anyways I will reinstall that again. So install the PL2303. So if it asks for .NET update, so you need to do that by connecting the laptop to the internet. It is, ignore that. Right, so at the end it will ask for to insert this USB to TTL converter. Right, insert this at any one of the USB slots of your laptop. After click on continue, and at the end it will ask for the restart the laptop. Don't restart the PC. Finish. Now go to this PC, right click, show more options. So in that manage, and in the device manager, in that ports, so there we can see the COM number here. So if you didn't find the COM number properly, like it will show you some error when you updated the laptop. So then go to update driver if it shows the error. Otherwise keep that as it is when you got the COM number. So then we need to select the 2008. Next. and installed successfully, then we'll get the same like COM number. So what's the COM number here? Note on the COM3, and now close it and open to the hyperterminal software. So in that, click on this yellow LAN symbol icon. Here three things now. Type any name you want, and then COM number which we got from the same this PC manage. Restore default. Name any name, select the COM number and restore default. Click on OK. Right, now keep this. And now on the power supply to the kit. So continuously we get in the data. So if we connect the heavy load here, so we can connect up to 1000 watts also. We have connected the 100 watts bulb, so that's why the increment in the kilowatt hour is very slow. So that we can see that 0.003 kilowatt hour. So that's the indication of 1 by 3200 blinking rate. So when the blinking rate is 2, that is 2 by 3200. Like that, when the blinking rate is going to be the 3200 count, then 3200 by 3200 1 kilowatt hour. Till that we can measure. Right, we can see that it's continuously streaming the data to the PC through RF communication.